Hello everyone, welcome back to the DSA lab where we learn data structures and algorithms step by step in a simple and beginner friendly way. In today's video, we are going to learn an important tree concept called constructing a binary tree from traversals. Many students feel confused when they see this topic for the first time. But don't worry, I will explain everything clearly using logic, diagrams and a small example. By the end of this video, you will understand how a tree can be reconstructed using traversal orders. First, let's understand what this topic actually means. When we say construct a tree from traversals, we mean that we are given traversal sequences of a tree, and using those sequences, we try to reconstruct the original tree structure. So this is not about creating a new tree randomly. Instead, we are reverse engineering the tree using the information hidden in the traversal orders. Think of traversals as footprints left by a tree. By carefully analyzing those footprints, we can redraw the entire tree again. To do this correctly, Inorder Traversal plays a very important role, which we will see next. A tree traversal is simply a way of visiting each node in a tree exactly once, following a specific order. Different traversal orders highlight different structural properties of a tree. Traversals are mainly used to visit and display all nodes, analyze the structure of a tree, convert a tree into a sequence form, like that. In this video, we focus on three important traversals: Inorder traversal, Preorder traversal, and post-order traversal. Understanding these three traversals in the key to constructing trees. In Inorder traversal, the visiting order is left subtree, root, right subtree. So we write it as left, root, right. This traversal is extremely important for tree construction. One special property is if the tree is binary search tree, then Inorder traversal always gives a sorted sequence. That's why Inorder traversal is very powerful. It tells us which elements belong to the left side and which belong to the right side of the root. For example, if a tree has nodes 2, 1 and 3, the Inorder traversal will be 1, 2 and 3. Now let's look at Preorder traversal. In Preorder traversal, the visiting order is root, left subtree and right subtree. So it is written as root, left and right. The most important rule you should remember is the first element in Preorder traversal is always the root of the tree. This rule is extremely useful during tree construction because the moment we see the preorder sequence, we immediately know which node is the root. For example, for the same tree, preorder traversal would be 2, 1 and 3. To uniquely construct a binary tree, we need two traversals, and one of them must be Inorder traversal. The valid combinations are Inorder plus Preorder and Inorder plus Postorder. Why is Inorder traversal mandatory? Because in Inorder traversal tells us how the tree is divided. Once we know the root, Inorder traversal clearly separates left subtree nodes and right subtree nodes. Without Inorder traversal, we cannot confidently decide this split. Now let's understand the core idea behind tree construction. The logic is actually very systematic and recursive. First, one traversal helps us identify the root. In preorder, first element is root, and in postorder, last element is root. Second, inorder traversal helps us split the tree. Elements to the left of root, left subtree, and elements to the right, right subtree. In third, we repeat the same logic recursively for each subtree. Once you understand this recursive pattern, tree construction becomes very straightforward. Let's now understand this concept using a concrete example. We are given inorder traversal D, B, E, A, F, and C. Preorder traversal A, B, D, E, C, and F. From preorder traversal, we immediately select the root. The first element is A. So, A becomes the root of our tree. Now we move to inorder traversal to split the tree. Let's now construct the tree step by step. First, root is A. In inorder traversal, A divides the sequence into left subtree elements D, B, and E. Right subtree elements F and C. Now we construct the left subtree. From preorder, the next root is B. In inorder, B divides D and E. So D becomes the left child of B. B becomes the right child of B. Next we construct the right subtree. From preorder, the next root is C. In inorder, C divides F, so F becomes the left child of C. By following these steps recursively, we successfully rebuild the entire tree. After completing all recursive steps, the final binary tree looks like this. Now let's summarize the key ideas. Preorder traversal tells us who the root is. Inorder traversal tells us how to split the tree. The construction process is recursive, and the same logic applies to any size of tree. If you remember these points, you will be able to solve almost any tree construction problem. And with that, we come to the end of today's lesson on constructing a binary tree from traversals. I know this topic can feel a little confusing when you see it for the first time, especially because we are not given a tree diagram directly, only traversal sequences. But I hope this video helped you understand that these traversals actually contain all the information we need to rebuild the entire tree step by step. The most important thing to remember is the logic, not memorization. One traversal helps us identify the root. Inorder traversal helps us divide left and right subtrees. And the same process is applied recursively. If you truly understand this idea, then tree construction problems become much easier and more logical. If this video helped you, please take a moment to like the video because it really supports this channel. And if you are new here, subscribe to the DSA lab where we break down complex DSA topics into simple, understandable lessons. So stay connected, keep practicing, keep questioning, and most importantly, don't rush the learning process. Thank you so much for watching, and as always, happy learning and happy coding.